Hello, my dear students. So, welcome back once again to my physics classroom. So, in today's class, we are actually learn about a new chapter called as gravitation. Now, I don't know how many of you know about the term gravitation, but it is a term which we usually see in our day-to-day life. If I'm dropping this pen, it comes down. See, it comes down all the way. If I'm throwing this object up, it again comes down. The planets are moving around the sun. The moon is moving around the earth. A lot of phenomenon that we see around us. A simple example, a jackfruit falls down, an apple falls down. All these phenomena that we see around us is due to the term known as gravitation. So when you talk about gravitation, it's not actually a bounded topic because it is a long range force, which means we'll have to go beyond our galaxy. We have to go beyond our Milky Way galaxy. Then only we have to understand, and only we will be able to understand the concept of gravitation. And to be honest, it is the least understood concept in reality, gravitation. And that's why many science fiction movies and everything has come out based on the topic gravity, gravitation, and that. So when you talk about gravitation here, based on our ninth standard level, what are the most important things that we have to learn? Let's see those things one by one. So in order to understand the basic idea about gravitation and a gravitational force, you'll have to think about a person who found it out. Who was that? He was a 22-year-old boy in the year 1666. He saw an apple fell down from an apple tree. And my dear students, please understand that it was not a red apple, it was a green apple which came down. Okay. So upon seeing that apple falling down from an apple tree, he started thinking, wow, the apple is falling down. Why can't the apple go up? The apple could have gone up, right? But instead, the apple was falling down. Now, what could be the reason for that? And it was really lucky that he was not sitting under a jackfruit tree, right? So when the apple falls down, he was thinking about it. Normally, if we were sitting under an apple tree and if an apple falls down, what do? We just run after the apple, take it, and we chew it and have it. But Isaac Newton, he actually thought about why the apple fell. And it was his theoretical output that we are learning today as the Newton's law of gravitation today. So my dear students, please understand that gravity can be observed everywhere around us. Between this object and this object, there's a force of attraction. Between every two masses around us, there is a force of attraction. Then the big question is, if there is a force of attraction between me and my laptop, why aren't we sitting? Aren't we stuck together? We are not sticking together, are we? Our laptop and the students were seeing me, you guys, and there is a force of attraction between me and you. But still, we are not sticking together. Why? Because please understand, my dear students, that even though we say that between any two objects having a mass, there is a force of attraction. Even though we say that between any two objects having a mass, there is a force of attraction. Please remember that gravitational force is the weakest of all the fundamental forces. It is the weakest of all the fundamental forces. We have electrostatic forces, we have electromagnetic forces, we have nuclear forces, weak nuclear force and strong nuclear force. Out of all the fundamental forces, my dear students, please remember and understand that gravitational force is the weakest of them all. That is why we are not sticking to each other, right? Now, according to Newton's law of gravitation, what it says is that suppose I'm having two masses m1 and m2. If I'm having two masses m1 and m2, the force of attraction between the two masses m1 and m2 is given by F is directly proportional to the product of the masses. What is it? The force of attraction between the two masses is directly proportional to the product of the masses. And one more term you have to remember here is it is inversely proportional to the square of the distance between them. My dear students, how is it? It is directly proportional to the product of the masses, and it is inversely proportional to the square of the distance between them. So combining these two statements together, Newton could conclude that F is proportional to m1 m2 divided by r square. So what is r? R is the distance between the two masses m1 and m2. What is r? It is the distance between the two masses m1 and m2. That is what you mean by r over there. Okay. So F is proportional to m1 m2 by r square. Or we can write it as F is equal to G m1 m2 by r square. So tell me, what do you mean by G? G, my dear students, we call it as the universal gravitational constant. G is known as universal gravitational constant. And what is the value for G? The value for G is 6.67 into 10 to the power of minus 11. And when you write that value, we have to write the unit also. The unit will be Newton, corresponding to force. We know that the unit of force is Newton. Meter square, that is corresponding to R square per kilogram raised to minus 2. So the value for G, never ever forget that. It is a universal gravitational constant. It is universal value. It is accepted all over the world. And no one has disproved it yet. When you become more interested in the topic, you can try to disprove it. Let's see how it goes. So F is equal to G m1 m2 by r square, where F is a force. Remember, it is a force of attraction between the two masses. Please remember that gravitational force is always attractive in nature. What is it? Gravitational force is always attractive in nature. It is never ever repulsive. It is always attractive in nature. Another point you have to remember here, it is the weakest force in nature. What is it? It is the weakest force in nature. Then it is a central force. Very important, guys. Please remember, it is a central force. Suppose I'm having a mass m1 here, another mass m2 here. Please remember, the gravitational force between m1 and m2 will be acting between the line joining the centers of the two masses and not from the surface. Where is it acting? It is acting between the line joining the centers of the two masses. So do remember that one also. So it is attractive in nature. It is the weakest force. It is a central force. So this is a basic idea about Newton's gravitational force, and I hope that is very clear for you. All right. So thank you, my dear students. Thank you.